Okay. Radhe Radhe everyone. Um, okay, so I think that took a little bit long today to stream. So should I wait for people to come or like should I start with it directly? I think we should be okay to start with it, no? I think we should be okay to start. Okay, so let's go with the first problem. It is very easy. Okay, very simple and very easy. Okay. You're given a positive integer n, determine whether n is divisible by the sum of the two following things: the digit sum of n and the digit product of n. Return true if n is divisible by this sum, otherwise return false. 99, what is the product of the digits? 9 into 9, 81. What is the sum of it? 9 plus 9, 18. Add 81 and 18, it becomes 99, okay? 18 and 81, if you add it, it becomes 99. And is 99 divisible by 99? Yup, it is divisible. So it's a truth. 23, 2 plus 3 and 2 into 3. So 2 plus 3 is 5 and 2 into 3 is 6. 6 plus 5 is 11. Is 23 divisible by 11? Nope. 22 is divisible, but 23 is not. So it's a false. Okay. How to do it? You can do it in just one, using two variables only. Temp is equal to n and sum is equal to 1 initially. Why is it sum is equal to 1? First of all, I am going to find the product and then I am going to find the sum. Okay. So whatever the product is going to come, I am going to add every digits to it. Simple. So for every digit, find its product. Okay. And after that, for every digit, add it to the sum. And return n is divisible by sum or not. Okay. This one was very simple. I don't think there will be any doubt regarding this. So I'll just move on with the next problem quickly. Okay. Now this problem is interesting. Okay. You know what? Like what happened when I just first of all I visited this question: the count number of trapezoids one. I was in a dilemma that whether do I need to do this according to this description, count number of trapezoids 2, because I didn't read the whole question. Okay, it was given that it has to be parallel to the x-axis. Okay, it is given. It is given that it is parallel to the x-axis. Okay. Now, if this wouldn't have been given, then that will be a really great problem. Okay? I mean, not a great problem. It will be like very difficult to uh, make a solution out of it. Okay. So let's understand what this question is telling us. Count number of trapezoids 1. You're given a 2D integer array points where points of I is equal to xi, yi. Okay, you're given some points. Why aren't much people over here, or is it so? And you guys are okay? Yeah, there are 4 people watching it. You guys can be interactive in the live chat. Okay, only 4 people watching it. Okay, so horizontal trapezoid is nothing but it is a convex quadrilateral with at least one pair of horizontal sides, and they are parallel to the x-axis. Okay, what do I mean by horizontal sides? That is, they are parallel to the x-axis. And two lines are parallel if and only if they have the same slope. Okay, so there is one pair of horizontal sides, and obviously they are parallel. Okay, because if it is parallel to the horizontal, if it is parallel to the x-axis, if two sides are parallel to the x-axis, so they are also parallel to each other, right? So it is going to be like this. It is going to be like this. This and this. These are parallel to the x-axis. Okay. See this. This and this are parallel to the x-axis. This and this are parallel to the x-axis. So you have to find the total number of trapezoids from here. And your answer can be very large, so return it modulo 10 to the power 9 plus 7. Now let's say you have various number of points. Okay. Now if you look at it, or let's say there is a point like this also. Okay. Okay, I won't use the same color. I will use red is fine, I guess. There's a line over here. There can be a line over here also, and there can be a line like this also, right? I am drawing it differently, okay, but what when I am talking about line, so it is like the line that is joining these points. Okay, now if you go for this, there's a line over here. This doesn't have any line, this doesn't have any line, this doesn't have any line. Okay, so for all the points, okay, for all the points which are in a specific, uh, which are having a specific value of y, right? Because this will have a value of x1, comma y. This will be x2, comma y, right? Because y is constant, because they are parallel, right? x3, comma y. Similarly for this also, both of them will be having the same value of y, right? So for all the points that are having the same value of y, you can take out any two of the points. Okay, you can take out any two of the points. So over here there are 3 points. So if I am taking out two of the points, what will the number of combination? It will be 3c2. For this it is 2c2, right? What is 3c2? It is nothing but 3. What is 2c2? It is nothing but 1. So over here you can see there is only one line possible, and over here there are 3 lines possible. Okay, clear? Good. Now that you have found out what are the number of points that are having the same y value, okay, and you have grouped them. Let's say if you have grouped them, okay. Now the moment you have grouped them, it means that from here you can take any. Let's say there are also other parallel lines, okay, other parallel lines we don't know about, okay. There are parallel lines like this, and this, and this. So from all of these parallel lines, you can take any one line, and from this line, this parallel lines, you can take any one line, and it will form a trapezoid. I mean, it will form a valid trapezoid. That is what we want, right? Take any one line of it, because if you are going to add this, let's say I'm taking this line, okay. This is a valid trapezoid. This is a valid one. Sorry. This is a valid one. Okay. This is a valid one. So all of them are valid, right? For any one of you take, all of them will be valid. So what is the equation now? The equation is nothing but, apart from that specific point, how many other trapezoids are possible? Okay. So what we can do is, first of all, we can group them. Okay. How to group them? You can sort the points on the basis of the y values, so that it becomes like in a group format. Okay. I'll just use one of the examples that is given. This one only. Okay. I'll use this. Okay. So by default it is sorted only 0, 0, 0, 2, 2. Right? It is sorted. Great. So for 0, how many are there? For 0 there are 3. Right? And for 2, how many are there? There are 2. So this is very similar to the one that we are doing, 3 and 2, right? I was just going to, I just did it, okay. So which means that from this 3, you can have 3c2, but you won't consider this 2 right now, because there will be some duplications if you consider it, right? Because it doesn't matter whether you are pairing this with this or this with this, right? So you have to pair only one of it. So for just to solve this, we can just focus on only forward traversal or only backward traversal, whatever you feel like. Okay, it doesn't matter. So this 3c2, initially this 3c2 is going to contribute nothing. Okay, but the moment this 2c2 comes, now this will get multiplied with this. Okay, and it will be added to the answer, right? Because that is what the mathematics tells us. Now let's understand a better problem. Okay, a more complex one. This is not a complex one. This is the easier one. So let's say if we are understanding, um, okay, so this we got 3 2, right? What if it will be like it was like 3 4 2 3 1, right? So how many total elements, how many total points are there? 3 plus 4 plus 2 plus 3 plus 1, and after grouping it, it becomes 3 4 2 3 1. Okay, great. So for this 3, it is going to be 3C2. It is not going to contribute, right? This 4, it becomes 4C2. What will it contribute? The multiplication of these. Okay. Now comes 2C2. What will it contribute? It will contribute nothing but the multiplication of this and this plus this. Okay. So we can also have a variable which is going to find out the sum of them. Right? Why this plus this? Because I just told you this example. So apart from these, whatever has been traversed, you can consider all the lines. Okay, so that's the reason this is this plus this. Now, again you go for something 3C2. What will be this? It is 3C2 into the sum of all of them. Okay, 1C2. Now see, this is the problem. Okay, 1C2 is not possible. Right? 1C2 is nothing but 0. And I'll just tell you one thing, like you for this C2 thing, it is n into n minus 1 by 2, right? So you don't need to check for 1 and 0 separately, because n into n minus 1, so for 1 n minus 1 becomes 0, and for 0 n becomes 0. So in either cases it becomes 0 only. Okay, so we don't need to focus on that. So let's now look at the code. ठीक है, क्या हो रहा है इसमें? First of all, I'm sorting it on the basis of the y points. I mean, on the basis of the y value of the points. I'm having 3 variables: answer, current, previous. This previous is actually not needed. It is like I just, it is not needed initially. Okay, initially you have to group them. How can you group them? Because initially current is 1, because one of the elements will be there in the group, first group. Then you're going to traverse, and if the previous element is having the same y value, it will be going to that specific group only. Otherwise, you have traversed that group and you're having a new group now. Okay, so you're done with the grouping. This ARR list is going to consist of all the groups. Okay, you got the groups. Now current is equal to air dot get 0. That is the first element, because you know that the first element is not going to contribute anything. And what is previous? Previous is nc2, right? This value c2. And what is c2? It is current into current minus 1 by 2, right? nc2 is n into n minus 1 by 2. Okay, then from 1 to n you're going to traverse, and for every specific element you're going to get what the current value is, multiply that with whatever has been occurred previously. Okay, and then add that specific value to the previous, because now that has become the past. Okay, now we are going to encounter now a different variable, and this is just for the modulo, because it was given that it may be very large, so you have to go with some modulo stuff. Okay. Okay, so any doubt regarding this? Anyone? See, as far as I know, even if you can't comment on this live chat, okay, it is because you're not subscribed to me, okay. But you can at least interact in the live poll, I guess. Okay, the live poll, I think there is no restriction on that. The live chat I have made some restrictions because like due to some things that okay, so like some things are there. So apart from that, I think like this is visible. This is right. Okay, I'll just check whether I'm audible or not. See, I'm audible. I'm as well as visible. Like there is no lag in the stream. So you guys can be a little bit responsive in the live chat. Okay. Anyways, it's okay. I'll move on to the next problem. I'll consider it as a yes. Okay. This is a hard problem. Number of integers with pop count depth equal to k. 2. But according to me, the part 1 of the problem, which occurred in yesterday's bi-weekly, okay, the part 1 of the problem, it was harder than this. Okay, unpopular opinion, but I feel so. Okay. You're given an integer array nums for any positive x. Define the following sequence: p naught is equal to x, p of I plus 1 is equal to pop count of p of I. Okay. So what is the pop count depth of x? It is nothing but, let's say if I'm having a value of not 6, okay, let's have some other value, 7. Okay, so what is its binary? It is 1 1 1. So how many set bits are there? 3. So now 7 becomes converted to 3. What is its binary? 1 1. How many set bits are there? 2. So 3 becomes converted to 2. Set bits 1 0. So number of set bits is 1. It converted to 1. Now for 1 also the set bit is 1, right? But this is a recursive thing. So the moment we reach a 1, we are going to say that okay, we have reached it. So what is the depth of it? 1 2 3. Right? So the depth of 7 is 3. Okay? So the pop count depth of x is 3. Pop count depth of 7 is 3. Okay? So that is what I didn't go through the complex language that the question was telling us. So I just explained it in simple words. You're also given a 2D integer array queries where each queries of I is either 1 LRK or 2 IDX val. Okay. So if it is 2, it means that we are going to update nums of IDX index to val. Okay. Otherwise, you have to determine the number of indices in the range of L comma R such that the pop count depth of all those indices which are equal to k. Okay, the number of indices between L comma R whose pop count depth is equal to k. In simple terms, in very simple words. Now see, what is the pop count value over here? It can be from 0 to 10 to the power 5, right? So this is a very interesting thing to note. And I'll just tell you why. Okay, because even if you're having 10 to the 15 is over here, right? Nums of I is less than equal to 10 to the 15. But even if it is 10 to the power 18, then also it will be 5. Okay, because 10 to the power 18 means that there are, let's say, at max there can be 61s, right? 61s, because see, it is decreasing at a very huge rate, right? Let's say there are 61s. There are 61s, okay. 60 times there are ones. So directly that number gets converted to 60. Then that number gets converted to the number of ones in 60. And then that. So it is not that much as we are thinking it to. Okay. It is very small. K. So now since there are two types of queries. One is the update and one is the range sum. Range sum, that is it. So one thing that should come to your mind by default is segment tree, because that is the only type of data structure which can handle this kind of problems, right? Now since that is the only kind of data structure that we can handle it, so we can directly go for that. Okay. So I won't explain you what we are doing, because you know how segment tree works. See, this is the code for the segment tree. This is the code for the segment tree, nothing else. Okay. This is the pop depth. Okay, this is the depth. So what is the depth? Answer is equal to 0. So while n not equal to 1, find the number of bit count in it and replace that value with n and answer plus plus, return answer. So this is the pop depth. Okay, great. Now what is the pop, like what is the answer that we are going to have? So m is query of length, n is number of length. Okay, pop is nothing but the I don't think pop was needed anyway. Okay, yeah, pop was not needed anyway. So I just mentioned something, but it is not needed at all. Answer is a list. Okay. Now see, I'm having total 6 modified arrays. What is this modified array going to consist of? That is, for every specific number in nums, I'm going to find its depth, pop depth. If its pop depth is 0, I'm going to put in modified 0, 1. If it is 1, then modified 1 will have 1 in that specific position. Modified 2 will be having 1 in that specific position, and so on. So I'm having total 5 segment trees. Because if I am updating a specific number, it means, let's say, a specific number which had a pop count of 1. Now I'm updating it with a number which has a pop count of 2. So for the segment tree 1, okay, so for the segment tree 1, wherever this number was present, there was a 1, and for segment tree 2, wherever this number was present, there was a 0, right? Because if you look at this condition, this part, I'm going to put 1 only in the places where I find out ki chalo pop depth is there, is 1, is that specific element. Okay, so ye 0 hai. So what is now my operation to do? I'm going to update this 1 to 0 and this 0 to 1. Okay, so there are total 2 updates. So if you look at over here, whenever I'm getting 2 and I want to update it, there are 2 updates. One is what was the initial value of the pop depth and what is going to be the new value of the pop depth. So whatever the initial value was, it will become 0, right? So this is the update part of 0. And whatever the new value will be, it will become 1. So this is the update part for the new value. And if k1 is equal to k2, so if the initial value and new value are having the same pop count depth, so it is not going to contribute anything, right? So we can go with it. Else if for every query you have to find out what is the value of k that we have to consider. Okay, so is the value of k 0? If it is 0, go for range sum in segment tree 0. If it is 1, go for range in segment tree 1, and so on. So one thing that you could have optimized this code with would be, instead of having every specific condition, you could have made an array of segment trees. Okay, that would also work. An array of segment tree would have also worked, but since I was very crunch on time, so I just went on with this. But I think this was more time consuming than array of segment tree. Okay, so you could have also made an array of segment tree. It would be the same thing. Okay, and once you're done with it, find the result. Result is basically whatever is there in the answer. You're going to copy it to the result and return it. Okay. Is there any doubt on this? Because this is the last question that I would be explaining. This is the last question that I have explained till now. After that, I will be just rating the problems and then ending the live stream. Okay. So if there is any problem, it is now. Now is the time to write it in the live chat. Okay. Oh man, you guys can be more responsive. Yeah, interactive. थोड़ा interactive तो हो सकते हो यार. अब ये क्या ही समझाना, ये तो टीएल ही आ चुका था इसमें. Is this using Gemini? Submission length exceeds limit. Okay. Alright. इसका निकाल सकता हूँ क्या मैं? हाँ, won't be a right thing. What if I submit this solution? Gonna analyze the complexity for this. Why is it the analyze complexity? Okay, is it coming only if you are having TLE? I think it comes only if you are having TLE. Okay. Okay, anyways. चलो यार करते हैं इसको खत्म. Let's rate the problems. The first problem easy था भाई. First problem बहुत easy था. First problem was very easy. The second one was count number of trapezoids. So considering this, it will be like between easy and medium. See क्या था? Okay, segment tree. So if you're using segment tree, it will be over here only, right? Above medium and below hard. And D was since I don't know what the solution is for D, and I'm getting a TLE, so I'll just consider it as hard. Okay. But I may be wrong. Maybe it is like some easy solution is there. But since okay, since it is D, so we have to respect it. Okay. Okay. So yeah, that's it. That's it from my side. That's it from my end. Thank you guys for joining. Okay. चलो यार. Bye. Bye guys.